Hello NI students, welcome to the CAD/CAM laboratory. In this lab session, we are going to learn about how to create the parts of Cotter joint assembly and how they can be assembled together, and how we can go for generating the orthographic views, that is front view, top view and side view of the Cotter joint assembly. As it can be seen here, the Cotter joint we'll have three parts here. So this is the bill of materials with respect to the Cotter joint, and in this bill of materials we can see that part number 1 is socket, and part number 2 is spigot, and part number 3 is cotter, and this is the isometric view of the Cotter joint. This is what we need to get at the end of this lab session. We need to get the three-dimensional assembly of the Cotter joint. So in order to get that, first we have to model the individual parts. First we have to model the socket, then spigot, then the cotter. Okay, and spigot will be inserted inside the socket, and this spigot and socket will be locked with the help of a cotter. And as we all know, the cotter joints are used to transmit the axial load. One end of the rod will be made in the form of socket, another end of the rod will be made in the form of spigot, and spigot will be inserted inside the socket, and the spigot and socket will be locked with the help of cotter. Now let's go for seeing the part drawing sheet. So this is the part drawing sheet which will be given for you in the examination. Based on this part drawing sheet, you should go for modeling the socket, then spigot, then cotter, and all the three modeled parts should be assembled together, and we have to convert the 3D assembled view into the 2D drawings. Okay, that is what we need to do in this lab session. So first let's take up the socket part. Okay, so part number 1 is given here. So for the part number 1, that is socket, they have given the front view and the top view. So this is the front view of the socket, and this is the top view of the socket. As it can be seen here, the socket, the left side of the socket here, okay, is having some rod. Okay, so rod of diameter 25 mm, and this is the outer diameter of the socket, that is 45 mm, and the inner diameter of the socket here is 30 mm. Okay, and this portion will be called as the socket end, and the outer diameter of the socket end can be seen in the top view. It is 64 mm here, and again the inner diameter of the socket end is also equal to the inner diameter of the socket. So this socket can be splitted into three parts. This is rod part, this portion will be the socket part, and this will be the socket end part. Okay, or socket end zone. Okay, so as it can be seen in this front view and top view, okay, so the diameters are given. The meaning is that this is hollow cylindrical component. Okay, so since it is hollow cylindrical component, we are going to use the revolve feature, and whenever we want to use the revolve feature, we need to create half of the profile of the component from its axis. So in this case, we need to create this upper profile here. So I am going to choose this as the starting point. From this starting point, I am going to draw one vertical line, then horizontal line, then vertical line, then horizontal line here, then vertical line, then horizontal line, again vertical line up to here, then the inner edge here, inner edge corresponding to the inner wall of 30 mm diameter. Then horizontal line will be drawn, then again vertical line, then again horizontal line. Okay, so this is the upper profile with respect to the central axis of the socket. So this will be constructed in the front view. So therefore I will go to the SolidWorks, go to the part. Okay, sorry, so close this one, go to the part, create new part. Okay, then okay, then select the front plane, and okay, then click on the sketch command in the sketch tab, then go for selecting a line command, and then from the origin, first draw the vertical line. Now this vertical line corresponds to the radius of the rod here, that is 25 by 2, and then draw a small horizontal line. You need to remember that they have not given any length for this rod portion of the socket, so we can take this rod length suitably. Okay, so therefore I am going to draw one horizontal line to indicate the length of the rod portion of the socket, and then I will draw this vertical line here. Okay, so then vertical line, then again horizontal line to represent this portion will be constructed. Okay, and then again small vertical line here, again from this point draw horizontal line, and then we will draw one vertical line to represent this edge. Okay, and then again horizontal line will be drawn up to somewhere here. Again one vertical line will be drawn to represent this inner edge here, and then come back to the starting point. So now I am going to add the dimensions for this created upper profile of the socket. So first let me add the overall length, that is 89 mm. So this 89 mm is actually from this line to here. Okay, so therefore this corresponds to the distance from this line to this line. Okay, this should be taken as 89. Okay, and this portion, this particular line length represents the rod length, which is actually not given here. So I'm going to take this as around 20 mm. Okay, and then what I do is I go for adding the diameters now, or before to that let me add even this length here, not this length, this length. So the distance from this line to this line is 25 mm. So therefore let me add this as 25 mm. And then I'm going to add the distance from this particular line to here as 12.5. That is, distance from this particular line to here is 12.5. And then we can go for adding the diameters now. So here the smallest diameter is 25 mm, then next to that is 30 mm. Okay, next higher diameter is 30 mm, then next diameter is 45 mm, and the outer diameter of the socket end is 64 mm. So therefore let me start with the smallest diameter, which corresponds to here, that is the rod diameter. So rod diameter, but here we need to give radius values because we are constructing only the half of the profile from the axis. So therefore we need to enter the radius. So diameter is 25, therefore I am going to enter here as 25 by 2. Okay, once this is entered, then next here diameter is 30 mm. So therefore I am going to give the distance between this line to this line here. So this should be 30 divided by 2. And then after that I am going to give the next higher diameter, that is 45 mm here. That is, distance between this line to this line should be 45 by 2. Okay, then I am going to give the outer diameter of the socket end, which is 64 mm. This can be seen actually in the top view. So this is the top view. Here you can see the distance from here to here in the top view corresponds to the distance from this line to this line in the front view. So therefore the distance between this line to this should be how much now? This should be 64 by 2. So I'm going to give this as 64 by 2. So now you can see the sketch is fully defined. All the entities of the sketch are turned to black color. So I'm going to exit from the sketch now. Okay, I'm going to keep the sketch in isometric view, and I will click on the front plane so that I can confirm the sketch is created in the front plane. Once it is done, now I'm going to select the sketch again. Sketch 1 is selected, and then I will go for features tab. Then there I am going to select the revolved boss option. Okay, so select the revolve option. Now since we have not created any axis for this sketch, the software has not automatically identified the axis for adding the material about an axis. So what we need to do is we have to first select the axis of revolution. So which should be the axis of revolution here? Axis of revolution should be this line. Okay, so this line corresponds to this horizontal line in this sketch. So select this one. So software will add the material for the created profile. Okay, about the selected line. Around the selected line, material will be added for the created sketch profile. Okay, then click on OK. Is that clear? So therefore this is the initial draft model of the which one socket. But this is not complete. So if you want, you can turn on the hidden edges here. Okay, so but in this front view with hidden edges, as we can, if we try to compare this front view with hidden edges with this front view here, okay, so we have not actually made. So as we can see in the top view of this socket here, as we can see in the top view of the socket, okay, there is a Cotter hole here. This Cotter hole is having a width of thickness of 7.5 mm, and this Cotter hole is having width of 33.25 mm at the top, and as we move from top end of the Cotter hole to the bottom end of the Cotter hole, the right edge of this Cotter hole is remaining straight, while the left edge is tapering. With a slope of 1:30, means for every 30 mm decrease in height, 1 mm width should be decreased. Okay, Is that clear? So therefore what we do now is this Cotter wall should be there from you can see this is the hidden edge appearing here. So this hidden edge represents that this Cotter wall is present in the socket zone as well as slightly inside the socket end zone also. So this is the socket end zone, this is the socket zone. So Cotter wall should pass through socket zone as well as the socket end zone. So this Cotter wall is actually present, so you can see here. So this is the right edge, okay, the right edge of the Cotter wall. Okay, so this right edge of the Cotter wall is at a distance of 22 mm from the socket end here. Okay, so while this particular line is at a distance of 25 mm. So this clearly indicates that, okay, the length of the Cotter wall which is present inside this socket end, okay, in this zone is 3 mm. Okay, so the Cotter wall here, as we can see in this top view, this Cotter wall has the length of the Cotter wall which is present inside this socket zone is 3 mm. So therefore that has to be entered. So therefore what we do now is we go for creating this Cotter wall, okay, from top to the bottom. Okay, such that the right edge should be straight and the left edge of this Cotter wall should be tapered with 1:30 slope. Okay, so this has to be created again in the front view. Okay, so therefore I am going to turn back the hidden edges. I am going to hide the hidden edges now. I am going to keep this in isometric view. Now I am going to select the front plane again. So and then I will go to the sketch tab, sketch command tab. Then I will go for selecting the sketch tab. Then again keep it in front view. Now what I do is I am going to select a line command. Okay, so as I showed here, the right edge of this Cotter wall should be straight, okay, while the left edge of this Cotter wall should be tapered. So therefore what I do now is from somewhere here, okay, I am going to draw one straight line, okay, and then I will draw one horizontal line, okay, then I am going to draw one tapered line, okay, then the horizontal line. Okay, so this is how will be this is the rough profile of the Cotter wall in the front view. Okay, so we need to add the dimensions now. So as I showed here, this Cotter wall, okay, is present inside this socket end for how much mm? 3 mm, because here it is shown this particular dashed line represents the right edge of the Cotter wall. If this dashed line is representing right edge of the Cotter wall, since this distance is given as 25, this is 22, then the Cotter wall is present inside the socket zone for 3 mm. 25 minus 22, it will become 3. So therefore what I do now is first I am going to give I will go to the smart dimension now. I will select this line and this one, and I am going to give this value as 3 mm. Okay, so this is what I am going to define first. Then what I do is I am going to select the midpoint of this right edge. So I am selecting the midpoint of this right edge or the right line that I have created here, and I am going to select by holding the control key. I will select the origin, okay, and I will bring these 2 points on the same line. That is, I want to make these 2 points to appear on the same horizontal line. So I am going to give the horizontal relationship. By doing this, okay, what we have established is, okay, this particular line that we have constructed is equally present above the origin and below the origin. Means with respect to the axis of the socket, okay, this right line, okay, or this right edge is equally projected on the top and equally projected to the bottom side. So that is what we have done by making the midpoint of this line horizontal with the origin. Okay, so then what I do is since this Cotter wall should be there from ear to ear. Okay, so I'm going to select the top end. Okay, top end now. Top line. This top line will be selected, and then by holding the control key, I'm going to select this top edge of this socket end. These two, this and this will be selected, and then I'm going to make them as collinear. Okay, is that clear? Because the wall should be there from ear to ear. So then what I do now is I need to give the value of Cotter wall width. Now Cotter wall width is given at the top. At the top, Cotter wall width is 33.25. Okay, but this distance is given up to from this edge. Okay, so therefore what we do now is I am going to define smart dimension. I will go for smart dimension from this edge to this point. Okay, this value should be how much now? This should be 33.25 mm. 33.25 mm. Okay, so from here to here it is 33.25. Okay, and again let me check it. Okay, I think somewhere this is actually not correct, because this particular distance of 33.25 is from here to here, but as we can see in this part drawing sheet, okay, this 33.25 should be there, should be measured from this point, which is on this outer surface of this socket. So okay, is it not? So therefore the distance from the this point, which is lying on the outer surface of the socket, to here is 33.25, but this point is not on the outer surface here. So what we need to do is I'm going to just delete this one now. I'm going to delete the added dimension. Then what I do now is I'm going to construct one more line now. Okay, so where that line will be created is, so I'm going to create that line somewhere here. Okay, so I'm creating this line somewhere here now, and then what I do is I'm going to select this line and this outer surface of the socket, and then I'm going to make them as collinear like this. Okay, once it is made like that, I will also select this line, which is now collinear with the outer surface of the socket, and I will use this for construction purpose. Okay, then what I do now is I'm going to give the distance between this line to this point. So this should be now 33.25. So how much it should be? 33.25. Okay, is that clear? So then what I do is, so I am going to give the slope value. So now you can see this we have only one blue color line appearing here, meaning is that this line is not constrained. If you try to move this line now, okay, so you can see the angle of this line can be varied. So I am going to bring it to something like this. Then okay, I am going to give the slope of that line. How to add the slope of the line? That is very important. Now the slope of the line can be given as per this 1:30 ratio. Okay, so what this 1:30 ratio says, when we move from this point to this point, okay, in this direction, in the vertical direction, okay, so for every 30 mm decrease in height, 1 mm width should be decreased. But what is the distance from this from here to here? Okay, the distance from here to here is actually 45. Is it not? So for 30 mm decrease in height, if 1 mm width should be decreased, then how much should be the width should be decreased for 45 mm decrease in height? Okay, because when we move from here to here, actually we will be moving down by 45 mm. Okay, so therefore if I want to measure this, then what we have to do? I have to divide this 45 by this slope of 30. Okay, 1:30. Therefore 45 by 30 will be give us will come around 1.5. So there is no need to remember. See, from this point to when we move from here to here, the width should be decreased. So I will select this point, and then I will select this point. Okay, so I will give the distance from the top end of the tapered line and the bottom end of the tapered line. I am defining the horizontal distance between the top end of the tapered line and the bottom end of the tapered line. This should be 45 by 30. Okay, because we are moving down by 40 mm. Okay, so therefore for when we move down by 30 mm, 1 mm should be decreased. Therefore when we move actually by 45 mm, then how much width should be decreased? That can be found by dividing 45 by 30. So enter it. Okay, so this is 1.5. Automatically software will take that. Therefore now you can see the sketch is fully constrained now. Okay, so I am going to you can see the sketch is fully defined. So I will come out of the sketching mode now. I am going to keep it in isometric view. Okay, you can press Ctrl 7 to get the isometric view, Ctrl 1 to the front view, Ctrl 3 for getting the side view, and Ctrl 5 for the top view, and Ctrl 7 for the isometric view. Okay, so you can use those shortcuts for changing the views. Otherwise you can change the views here also. Whichever you feel comfortable, you can use that. Then what I do is I will select the sketch 2 now. You can see when I select the sketch 2 under feature manager. Okay, so it is appearing exactly at the middle of the socket. Okay, is it not? So therefore it is exactly, this sketch has been created exactly at the exactly on the front plane. So therefore what I do now is I will go to the features tab. There I am going to select extruded cut, because I need to cut the material within that profile now. Okay, and we need to cut the material within the profile for how much width. So that can be seen in the top view. So you can see this is the cutter hole. Okay, and this thickness of the cutter hole is 7.5 mm. So therefore what I do now, I go for using extruded cut option now. Okay, after selecting the sketch. Now right now we are in blend mode, means we are trying to cut the material on one side of the sketch, but we need to cut the material. When we try to cut the material, it should be on either side of the axis. So means in this case, since the sketch is created exactly on the front plane, we need to cut the material on either side of the created sketch. That's why we will change the direction to mid plane. So from the sketch on either side we have to cut the material. Then it is asking how much, for how much value. It should be for 7.5 mm depth. Okay, then click on OK. Okay, so now you can see this is going to be the top view, this is going to be the front view, and if you want you can turn on the hidden edges now, and you can see this is the left tapered edge and this is the right straight edge. Okay, so this right straight edge is actually present in the socket zone for 3 mm length. Okay, so this is what we get. But when we try to check the top view here, okay, and when we try to compare the top view with here, you can see this cutter hole side faces are actually having round, actually they are rounded. The cutter hole side faces are rounded like this, means we need to add fillets here. But right now these are looking like flat faces. Okay, so therefore what we do now is I will bring back the model to solid form, and then I will keep it in isometric view. So now in R2, means our objective is to make this particular face as round, and this should also be rounded here. Okay, on the bottom side. Okay, this should be rounded, and then here also this should be, this particular face should be rounded. Okay, is that clear? So therefore what I do now is I am going to use in features tab. Okay, in features command manager I am going to use the fillet option. Okay, this fillet options will be used. Then I am going to select the edges about which the fillet should be added. So here it is asking, okay, edges, faces, features and loops. Here items to fillet. So I am going to select the edges now. I will select this vertical edge. Okay, but right now it is taking the fillet radius as 10, but as we can see here, the width, this thickness of this cutter hole is 7.5. Therefore this fillet radius should be half of that. So therefore 7.5 by 2 should be added as the fillet radius. So I am going to give the fillet radius as 7.5 by 2. Okay, so which is going to come something like this. Okay, so this is so this preview says that we are trying to give the fillet on only about one edge, but this same thing has to be given for all the remaining 3 edges. So I am going to select this one. Okay, edge 2 is selected now, and edge 3, this one. Okay, and edge 4. This is on the top side of the socket. Same thing has to be done for the bottom side. I am going to tilt it now. I am going to rotate this slightly, and I am going to select this edge 5 here, edge 6 here, not the face. I am going to delete this face selected. This edge, you can see the selected edges are appearing in now in blue color. Select this. Okay, once all the 8 edges are selected, 4 on the top side of the socket, 4 on the bottom side of the socket, you can click on OK. Now you can see, okay, so fillets have been added, okay, around those selected edges. Okay, and now if you try to keep it in top view, this is how it looks. Okay, so this is exactly same as this top view here. Okay, is that clear? So this is what you need to do with respect to this socket. Okay, so again I am going to bring this to isometric view, and as you can see in this front view, somewhere here it looks like there is a fillet. Okay, and even this particular circular edge is circular edge as fillet. Okay, here also there is a fillet. Okay, here also there is a fillet. If you want to add the fillets at this one, okay, you can use this fillet option, and you can go for adding the fillets here. Okay, here, and fillet can be added here. Okay, but they have not mentioned what is the fillet values there. But somewhere here they have mentioned all unmentioned fillets and rounds should have radius of 3 mm. So it is given here. So what I do now is if you want to add the fillets there, so I am going to use the fillet option again. I am going to select this one first, but unless otherwise mentioned it should be 3 mm. It is given here. So I am going to use this as 3, and then I am going to use this one also. Okay, and then I'm going to use this. Okay, so only these three I'm going to select. Okay, if you want to add few more fillets depending upon the front view and top view of the given part drawing sheet for the socket, okay, you can go for selecting the other circular edges also. Give it okay. So this is how it looks. Okay, so in the top view, in the front view, now it is going to appear like this. So now you can see there is a fillet here. Okay, so there is a fillet here, and then there is a fillet here. Okay, so we have given fillet here. Okay, and here also it looks like there is a fillet. So if you want to really add that one also, select fillet and select this one. 3 mm should be given unless otherwise mentioned. Give fillet there. Okay, so this is what you need to do. If you want to add fillet here, okay, that is left to you. So therefore what I do now is I'm going to keep this in isometric view. So, and I'm going to save this file now. So I'm going to save this file on the desktop. I'm going to create a new folder on the desktop by name Cotter Joint. Okay, so in that inside that Cotter Joint folder, now I'm going to save this as part 1, and part 1 we have created a socket of the socket of the Cotter Joint assembly. So I'm going to give the name as a socket. Okay, then click on save, and the file will be saved as a .prt file. Okay, so this completes the modeling of which one, socket, that is part 1 of the Cotter Joint assembly. Okay, next we will see how the second part, that is spy guard, how this spy guard can be modeled.